welcome to this new tutorial. Today we're gonna learn how to do this fiery effects heart stylize. So there's a lot of work for that, but yeah, we're gonna look into this. So to keep it very simple, I'm gonna show you step by step how I built the heart and how I did the fire effect on the heart. Before we start with the modeling, I just wanted to say that if you want to model the heart by yourself with another software, just go ahead, skip this part and go to the simulation part. But if you want to learn how to do it in Houdini, then just stay and keep watching. Okay, so let's start by creating a box. This box is gonna be a polygon mesh. Then within the select mode, I'm gonna move one of the faces just to make it a little bit smaller. Then keeping the same selection, I'm gonna poly extrude that face so I have another box. Then I'm gonna select the bottom of the boxes and make a new poly extrude by pressing Q. Then once again, in the select mode, I'm gonna shape the box to make it like a heart. In this case, I just move the edge in the middle and just trying to find a way to shape the box so it looks like a heart. Once I have a shape that resembles a heart, I'm gonna use a poly split to divide each side of the heart, just so I can have a little bit more control when making the final shape. So from here, I'm gonna speed up the video so it's not too long. As you can see, I'm just doing the same all the time, pulling points, faces, edge. So it's just basic modeling here, using the same node all the time. If you have any question regarding the modeling, please just ask in the comment and I will get back to you as soon as I can. Once we have the basic shape, I will create two groups. One group will be a selection of faces from the top of the heart, which I will call beat up, and another group will be a selection of faces from the bottom of the heart, which I'm calling beat down. To create the group, just make a create group node and select the faces that you want them to be part of the group. And when you are done, remember to change the group name from group 1 or 2 to the name that you want. In this case, I'm calling them beat up and beat down, so I know which part of the heart I'm animating. Now we're gonna make a transform node. And this transform, we're gonna select which group we want to animate. In this case, I'm using the beat down group. And what I'm doing basically is just making 3 keyframes where the first keyframe start in the initial position, then I move the group a little bit out and then back to the first position. Then I just copy these three keyframe and paste it across the timeline. So I have like a beat animation. So it should look something like this. You have like a normal beat. But now I thought like it would be a good idea to copy paste this same node, right? And offset the keyframe that we already made a little bit forward or before. So we have like a secondary beat. And I think this makes it look much better than just having one beat. Instead of making it in one transform, it's much easier to just copy paste the same node and offset. Finally, just subdivide what you have and it should look something like this. I made like a final adjustment in the middle and move the edge in the middle a little bit down so that the B is more visible, and make a null node, and that's it. Now we are done with the modeling part. Let's move on to the simulation. So the simulation part is actually pretty simple. This is how it looks, or this is how it's supposed to look at the end. As you can see, I have 2 simulations running at the same time. This I can do because it's very simple and low poly. And the reason why I'm doing this is because if I do the simulation in one go, the V shape of the heart will get merged, and I feel like you kind of lose the heart shape. So that's why I decided to go this way. All right, so let's start by creating an object merge, and let's bring our model and create a dot network, or you can also create a pop network, which is basically a preset for the pop simulation. The pop network is like we already have all the stuff that you need. So let's dive into the pop network that I have already. And inside, all you need is a pop solver, a pop object, and a pop source. So the pop solver and the pop object, they're gonna remain the same. We're not gonna change anything there. Now in the pop source, one of the first options that we're gonna change, that we're gonna try, is the emission type. And the emission type is how the solver is gonna emit the particles. In this case, we're gonna focus on all geometry, but depending on the type of simulation you're making, you can select one or the other. Make sure that the geometry source is first context geometry. Then we move to the birth tab. Here, there's not much to change. We're gonna change the life expectancy from 100 seconds to 1. That means that the particle would only live 1 second. And the life variance is like it randomizes the life of the particle. Great. So now that we have the source set, let's move on to the pop wind. In the pop wind, we're gonna set the wind velocity in the y-axis. I think 1 is more than enough. If you try a higher number, you will see that it will go too fast. Then you have the amplitude, swirl size, like all of this stuff. For me, in this case, it was just more than enough to set low values in the amplitude, swirl size, and the roughness, just to keep like a little flame movement, when the particles are being emitted. But take your time here and try whatever you think you feel best. The pop limit basically limits particle within a cube in 3D space. It's very useful, and this is just to cut the heart by half. And this is the reason why I have two simulations, because I'm doing this simulation for only this side of the heart. Here you can see that I'm testing with different type of emissions, so you can see the difference. The only thing I changed in the pop limit was the size and the center. So I put it in where I wanted to take effect, and also check the kill outside open boundaries. That's also very important. This is what kills the particle when they reach the limit. And the pop kill will kill everything that is inside of the bounding type. In this case, I'm using bounding sphere, so I can kill the particles in the V shape of the heart, because otherwise, if I don't do that, then the particles of each side will merge, and I again will lose the V shape of the heart when I convert the particles to VDB and then polygons. Now that we are done with the simulation, let's add a VDB from polygon. And we're only gonna change the voxel size, which in this case 0.05 was more than enough to get enough details. Then for the other side of the heart, just copy paste those nodes. I mean, there's not much to do. Copy paste and go inside of the second simulation, the second dot network, and change the pop limit so it's taking the other side of the heart. Just move it to the other side. This is pretty much all you have to do here. Everything else remains the same as the other simulation of the other dot network. Now we need to combine these two BDB, and what we do here is that we change the operation to SDF union, and we turn off the resample. This way we're going to be able to combine both BDB so they merge. And now we're going to convert the BDB into polygons with a convert BDB node. Then let's catch both simulations so it's much easier to handle. Make sure that you have saved your project, that is set in a place where you can find it, so you can find the geo folder where your catch will be saved. So now that we have the catch, we play it and we see how it looks. And there are three things that we will need to fix here. One, which is, I mean, it's not a problem, but it will be nice to do, is to reduce the amount of polygons. So it's much easier to handle. Maybe you want to use this in a game engine, then you have a low resolution simulation. If you play it now, you can see that it's about 10,000 polygons per frame. And it's not like a very heavy amount, but I mean, we can reduce that to a much lower resolution simulation. For this, we're gonna use a polyreduce, and the polyreduce is a very useful node from Side Effects Labs. It basically lets you decide what's the maximum amount of polygon that the object or simulation should have. In this case, I'm setting up the amount to 1500. So I changed the target to output polygon count to 1500. And you can see that every frame, it will limit the polygon amount to 1500 only. Now, the second thing to fix will be the first couple of frames where the heart it's like coming out of nowhere. And to do this, we're gonna use a time shift. And with the time shift, what it does is this allows one to gain access to earlier or later frames or retrieve data always at a specific absolute frame. In this case, what we want to do is to make the simulation start after the heart is like completely, full. And this is, in my case, you need to check yours, but in my case is after frame 30 the heart is like complete, right? So what you do in the time shift is like you click in the frame and then you will see that it says dollar frame and just add plus, in my case 30, but in your case it might be a different number, but plus and then the amount of frames until the heart is full. And lastly, to make a loop, you can use the make loop, and this is like a super easy node to use. Just plug it in and that's it. In many cases it works right away. In some cases you have to do some changes in the start and end frame, but in this case it worked immediately, so it should work for you. And to finalize, just add a null, call it fire effects out or whatever you want, and let's move on to the shading. So now we are in the shading render part, so we're almost done with this tutorial. What I always do is I make a new geometry where I will use an object merge to bring the simulation, and so it's much cleaner, everything is like in a different geometry. We'll move it away, like find a position that I like. In this case, let's just move it a little bit in the y-axis, and then I add a material, which I will show you how to create the material for the cartoonish look, the stylized look. So I just paused the video to render some frames and see how it looks, to show you the options that you will have in the shader. You will have a primary color, a second color, which is like an outliner, and an outline thickness, so you can control how thick that outline is. I'm gonna show you then how can you do this if we dive inside of the material builder. And this is how it's supposed to look. It's not, it might look like too much, but it's actually very simple what's going on here. But before I explain you how it works, let me just show you something very quick. When you make a material builder, in case this is your first time working with shaders in Houdini, this is how it looks. And here we don't need displacement, so I'm gonna delete those, and I'm just gonna keep the global variables and the output and just put it on the side, the output. So back to the shader. The first thing we're gonna do is create a bind export. Keep in mind that there is a bind and bind export. We're gonna do a bind export and change the type to vector. And in the name, we're gonna type CE, which stands for color emission. Then we're gonna put a color mix. And in the first option of the color mix, the primary color, we're gonna put a lambert, a luminance, and a ramp parameter. Change the name of the ramp to primary color so you can identify it later, and don't change anything else, just leave it like that. In the secondary input, you're gonna put another ramp parameter. This time you will call it second color, and also change the type to color. All right, so let's prepare the last one, the bias. And for this, we're gonna use two vectors from the global variables. The first one will be direction from eye to surface, and the second one will be the normal. We're gonna then normalize the direction from eye to surface. So it's set into a scale of from 0 to 1. Then we're gonna negate it, so it's like inverse. And we're gonna do a dot product from the direction from eye to surface and the normal. When we have this new data, this new information, we're gonna use a compare, and the compare will be set to compare less than, and we're gonna make a new parameter that we're gonna set the type to float, and we're gonna call this one outline thickness. This is what's gonna define the thickness of the second color. Then we convert the output of the compare using an integer to float. So we convert this integer into a float and plug this into the bias of the color mix. Once we have all of this set, and this is all set also in the bind export as a color emission, you should have all of these options in the outside, and it should look something like this. The primary color will be a ramp from black to white. I advise you to change the interpolation to constant, so you don't get like a fade in between the colors. And from here on, I mean, it's up to you to play with the colors and find the ones that you like. Now I'm going to show you how can you render this using Mantra. Just create a Mantra node in the output level, in the output context. Select the camera, the range, then the folder where you want to store this. Don't forget to add at the end of the name of the file something like underscore $F or $F4, for example, dot the format that you want the export, whether it's EXR or JPEG or PNG. So you have all the files in the format that you want. And the last things to change is in rendering, you just change the rendering engine to physically based rendering. And that's it. Everything else stays the same, and have fun. And if you have any question, please make your question in the comment section, and I'll get back to you as soon as I can. Thank you for watching, and hope to see you in the next video.